Welcome to Programming Rainbow. In this video, we will continue on the series of Don't Eat the Yellow Snow written in C++ and SDL2. This is the 10th video, so if you want to follow along with this video, you can go to github.com, Programming Rainbow, and this one is going to be called Yellow Snow CPP SDL2. You can git clone this repository, move inside the directory, and open it up with whatever editor you would like. Okay, so this is where we left off with in the last video, the 9th video where we added the sound. I'm just going to run the actual last video code real quick because you're going to see basically what the game looks like. So this is the game running. Now there is a problem with this, and that comes in the fact that all of the timing of the game is based on the frames per second. Let me just press space again and replay it and see how fast the flakes are moving and how fast the snowman is moving. So the snowman moves pretty quickly here. I think of 300 pixels per second. And so are the snowflakes. They're falling down pretty quickly. Okay. So what happens if we make the gameplay slower? Maybe you have hardware that doesn't actually support. We're doing this very similar to 60 frames a second right here. It's not exact, but we're causing this artificial delay right here, which is timing at about 60 frames a second. But what if you're on hardware that is older than mine or slower? What happens if it can't actually hold 60 frames? What if it drops down to 50 or 30 frames a second? Well, let's find out what that happens. So I'm just going to double this. It was at 16 milliseconds for delay, kind of pausing for 16 milliseconds. So all this stuff happens probably in about a millisecond or two, and then it pauses for 16 milliseconds. Now we're doubling it. So it's going to be in the range of 30 frames a second, okay? But we're going to see that the snowman and the flakes move much slower now. They'll be moving at half speed. See, now the snowman moves at half speed, the flakes are moving at half speed. And what if you wanted your game to run faster? What if you had a 120 hertz monitor and you didn't want to run it at 60, you want to run it at 120? Again, this is not exact, but it's just for demonstration purposes. So I'm going to put it at 8 milliseconds here. Again, this is not exact, so. But now our game is playing way too fast, okay? And you can imagine if you have hardware that I said is struggling with the speed that it has, it may start slowing down and speeding up and slowing down because the CPU or the graphics may be used for other processes happening on your computer at the time, and it's not able to maintain a steady frame rate. So your game could be playing at full speed, but then sometimes slow down and then speed up. And so this is a very, very big problem. What we want to do is decouple the logic of the game, the movement of the game from the actual timing. So even if your game does slow down or speed up, the game plays at the same speed, no matter what kind of frames per second you're getting. So that's what this whole video is going to be about. And what we're going to be using is the C++. We're going to use this cron steady clock, which gives us 1/1000th of a second precision. Not milliseconds, not microseconds, but nanoseconds. And we are also going to use this thread sleep. Instead of the SDL delay, we're going to use this thread sleep. So these two things are going to give us very, very precise timing where we can actually try to target an FPS. We're also going to give back a delta time, and we're going to decouple, like I said, our movement. So we're going to try to make some FPS very precise. But even if we don't get the FPS we want, your game will still run at the speed it should run at, the movement of the stuff. So I just want to show that to you before we get into programming it so you kind of understand what I mean. So I was compiling the code that we ran from the video 9 where we added the sound, where we have this SDL delay kind of just statically set here. But let me show you the code that we'll end off with in this video so you can kind of get an understanding of what I'm talking about. So before we even start coding, I just want to show it. So let's go down here to video 10 where it's already the completed project with this FPS and everything. And let's go look at game again. So down here, we have this class now that we're telling to update. Instead of SDL delay, we're saying FPS update. Okay, so what's happening here is we have this class. I'm not going to do too much because we're going to do all this in a second here, but I just want to show it to you. We are using these, the steady clock duration and time points to keep track of the time and the time that has passed. And let me just show you here in the class or in the implementation. When we actually need to pause it for a calculated amount of time, we're using this thread sleep for. And again, this is a billionth of a second accuracy. This is down to nanoseconds. And we are going to kind of give it some leeway. That is 50 milliseconds leeway. So if one frame, we target it to sleep for so long and it sleeps a little too less or a little too much, it didn't actually hit the target we wanted it at, I'm going to give it 1/20th of a second play so it can actually say, hey, the next frame, I want it to delay a little more or a little less so we can get back on track. So it's going to have a little bit of leeway to kind of rubber band back and forth. But it's only 1/20th of a second. That's 50 milliseconds. So we are targeting in the nanosecond range, but I'm going to give it 50 milliseconds of wiggle room to allow it to try to catch up or to delay more if it needs to. Okay, so let me just show you this working. And this one actually has, separate from the actual setting the timing and creating this delta time, this actually has its own separate FPS counter. So even though it has logic to time the FPS, it separately has different logic that is actually counting frames. So I know what I'm targeting my FPS and I know what I'm really getting for FPS. The screen on my laptop only shows about 120 hertz. I'm only recording at 30 frames per second, but the game is going to be running. This FPS is going to tell me what my actual game is running at. So that rendering is happening, whether the panel refreshes or not, or you see it in the video or not. The game is actually running at the screen. So whatever this show FPS returns is what my game is really actually running at. The logic is actually running at that speed. The render is being rendered at that speed. That is the real speed of the game. Okay, so I just want to show this off to you real quick. So I'm going to be compiling the video 10 instead of source. So I'm doing source directory video 10, and I'm just going to tell it to clean. So it does a clean build, do the release build, and run it. Okay, so now I have this added method where I can tell it to show the FPS, and I'll do it down here. So I'm going to press F, and it's going to show the FPS, and it says I'm getting 60 frames per second. Like exactly 60. That's pretty good. What happens if we were to change it? So right here, I'm targeting 60. That's cool. What if we do it at 600? So that'll be 10 times faster. So I'm not going to do the clean this time. Since I'm still working the same code, I'm just going to tell it to build. So it's only going to build what it needs. But actually, I changed this header file, so it's going to rebuild everything. So can my system play this at 600 frames per second? Let's find out. Okay, I'm going to press F. And it says it's 600 FPS. Exactly. Like not even, that's pretty cool. So do you think it actually is playing at that? Let's try a little faster. Let's try 6,000. Or we could do anything. I could say 6,006. It doesn't really matter. Again, I'm changing the header file, so unfortunately it recompiles everything because every source file is pulling in this main header file. So you may be thinking that this showing 60, let's show it here now, and it's showing 606. You may be thinking it's just telling me the number, whatever number I put in, it's telling me that. But I actually know my system can only hit about 14,000 FPS. And that's not what I'm recording. So I don't know if that's what I can get right now. So let's just move right up to 14,000. So it can bump between 14 and 15,000. But again, that's not when I'm recording. That's just when I'm doing my own thing. So let's just see if it does this. And you notice the movement of the game hasn't changed. And you might be thinking this is a trick. I'll slow it down as well. And you'll see that it kind of, if at like 10 FPS, it'll kind of skip across the screen, but it will be moving the correct speed. Okay, press an F. And you see this time even though we asked for 14,000, we're not getting 14,000. We're getting 11 or 12. So what's happened here is my system cannot give me the frames that I want. Let's press F. Sorry, I pressed F. And my fan's kicking on and all this stuff. But the game is still playing at the correct speed. Okay? So it doesn't matter if it gives me the frames I want or not. It's going to try to give me the frames I want. But my hardware is going to reach a limit where it just can't do it anymore. But let's go the other way with it. Let's say I want it to be slow enough where you see it kind of glitching across the screen, but still be able to see that it's moving at the same speed. So how about 20 FPS? Hopefully 20 FPS, you can see that it's still moving at the right speed, but you can also see that it's kind of skipping across the screen because it's not got smooth movement. So the important thing I want you to understand is it's decoupled from the actual. Yeah, you can see things are moving the right speed, but they're kind of skidding down the screen. That's because it's only refreshing 20 times a second. So, and if I were to slow it down to 10 or 5, it would skip even further, but the movement is still the same speed. So basically, whatever happens, no matter what speed you target, what your hardware can do, even if it's not that, if I try to target 50 and my hardware slows down to 30, then 40, up to 50 or 60, and back down again, it's not going to matter because the game is going to be moving at the correct speed. That's based on delta time, basically. Based on right now, I'm moving 5 pixels every frame, and if I'm targeting 60 FPS, that's going to be 300 pixels per second. So if we think about 300 pixels per second in this delta time, what happens is I take that 300 pixels per second I'm targeting and I multiply it by my delta time, which was whatever the time of the last frame took. So if the last frame took a 60th of a second, I multiply 300 by a 60th of a second and I get 5. But if the last frame took a 30th of a second, I multiply 300 by a 30th of a second and I'm going to get 10. It needs to move twice as far because the frame took twice as long. And if the frame took half the amount of time, if it was 1/20th of a second, it's going to move at a smaller distance, say 2.5 pixels. And this is happening every single frame. So basically, it's using whatever the last frame time was. And that's the delta time, and it's multiplying the movement by it. So if your hardware is swinging, changing everything else, it's not going to matter so much. As long as it's kind of, over 15 or 20 frames a second, you start seeing it's kind of a little bit glitchy down there. But okay, so we have these two things that I just want to show here. I'm going to be using this steady clock. I'm going to be using the duration, the time point, and the now that gets the time. I think internally it's an int. It doesn't say that it is, but it seems to be represented as an int or an unsigned int or something like that. It's not a float or a double or anything like that. So it is down in nanoseconds, which again is a billionth of a second, but does seem to be in the style of an int, not a double or anything like that. And we are going to be using this to pause the game to let it sleep. We're going to be using this thread sleep. So we do need to pull in thread and we need to pull in chrono. Although I think SDL already pulls in chrono, it doesn't complain if I don't do it. I'm going to do it to do it properly. And then we are also going to set up a target FPS. Okay. So let's start working on this. I'm going to close this, go back up here to our source directory. And if you are following along with this, you'll want to grab, if you just clone this, you want to grab the source from video 9 and put it up here because video 10 is what's here by default. And we are working with what was there left over from video 9. So I'm going to go into main.h and we need to pull in both of those, chrono and thread. Although if you don't put chrono here, it still works because I think SDL is pulling it in, but I'm just going to pull it in. So we'll include chrono and include thread. And then I'm just going to add a const expr here for my target FPS so I can easily change it if I want to change it. And it's just going to be an int. And I'm just going to target 60. You can target whatever you like to, though. That's why it's here, so you can just change it. Okay, so we do need a new class. It's going to be called FPS. So I'm just going to create 2 files, fps.h and fps.cpp. So we'll do the if and def. main.h. So this class, I'm going to kind of dig into the private first because I just want to set up the member variables that we're going to be, needing to initialize in the initializer list anyway. So what's going to happen here is I have a target duration. That's how much I want the whole frame time of one kind of game tick to last. So if targeting 60 frames a second, I would want my frame time to last. I think it's 16.6666 on forever. It's at 6 for infinity. And that's how long I want my total frame time to be. Now there is my game takes up, or the logic of my game checking the game loop where it checks the input, where it updates, where it draws things. That takes time. So imagine I want 16.6 milliseconds if I'm targeting 60 fps, but my game update, the loop of the game update takes 4 milliseconds. So basically, I don't want it to be 4 milliseconds plus 16.6. I want it to be 16.6 minus 4 milliseconds. So it'd be 12.6. And I want to add that delay now to the end of my game loop so that my entire game loop took 16.6. So that's what I'm going with here. So I have this target duration, which is basically what I want my frames per second to be. How long does I want one loop of my game to actually take? So this isn't the target delay time. This is the entire time of one game loop with the logic happening, with the drawing happening, with the render update and all that, everything happening. How long should the whole thing take? So this one's going to be a const because it's not going to change, but this is going to be my target duration. So that's what I'm going to call it. And it's going to be this cron steady clock duration. Duration. And I'm going to call it target duration. So this target duration is basically going to be calculated from my FPS. What I want 60, and you can think about if it was in milliseconds, that would be 1000 divided by 60, which would give me 16.6 on forever. But it's not going to be in milliseconds here, but that's what it's going to be. It's going to be whatever that calculation is of whatever FPS I want with whatever amount of time that I've chosen in a second, whether it's milliseconds, microseconds, whatever. So since we're in nanoseconds, it's going to be like a billion nanoseconds divided by 16 or divided by 60. Sorry, if I'm targeting 60 FPS. If I'm targeting 120, that would be 1 billion divided by 120. And it's not a double, it's an int. So that's why I set it as an int. This one's also going to be const, and this is the max duration. So earlier I said I wanted to give it a little wiggle room. When you tell the game to delay, sometimes it delays longer than you wanted it, or it doesn't delay long enough. So you didn't actually hit the target that you wanted. And I want to be able to minus that or add that to the next duration of the next frame to get back on track. So, but I don't want it to be too much. So this is called the max duration. I should call it the max carry is what I should call it. It's what's the maximum amount that could be added to or subtracted from the next duration, basically. I'm going to change it to max carry because it doesn't make sense. It's the target is the max duration, or it's the target duration. And this is going to be of the same type. If I could type today. So we'll call this one max carry. Okay, so those are constants. Those are not going to change inside the game loop ever. So now I do need to actually keep track of things. Let's look at the game loop real quick. So here's my game loop. It keeps running over and over again, right? So if I go through my whole thing, delay and everything else, and after I'm done delaying right here, let's just say this is 5 minutes and 1 second in to my gameplay right here. This is the time mark right here at the the end of all my logic and my delay. Here's the time mark, right? So now this time mark is my last time that I finished the loop. So now when I come through and do it again, and I reach here, right? Let's say I reach here and I'm at 5 minutes and 0, 1 and like 14 or 14 and 4 whatever milliseconds, right? So this was my last time. I need to keep track of this last time because I need to say, oh, I'm 4 milliseconds past the last time when I did all my logic here, but I'm targeting 16. This is just 16 right here. So this thing right here, I could take this and subtract this last time, which is 501, right? I subtract them and I get that 4 milliseconds. This part. I'm not drawing this very well. I'm sorry about that, but it is actually, is that right? Yeah. So I end up with this, but my target is this. So then I can take 16 and I could subtract this. And this again is yeah. So now I can say 16 is my target, subtract what actually has occurred, which is 14. So now the new time here is 12, right? So I want to delay for 12 more so I can target that 16. So down here at the end, what really happened, maybe not 16 happened, but 17. So now I have this 5 and 1 second, and then I have this 0, 17. Okay. So now this is important because I'm off. I was targeting 16. I'm at 17. So now my last time is at 17. So this is important. I want to actually delay my next frame for slightly less, for 1 less. So my 16 is not 16 anymore. I want to delay it for 15 to keep on track. I hope some of that makes sense. But anyway, I need to know the time at the bottom of this frame. And then I need to know the time at the end of all my logic before I delay. I need to know that time so I can find out how much to delay. And then after I delay, I need to know the time again. This time will be the next last time that gets carried through, but I also need to know what I need to carry. So I need to carry a -1 millisecond. So this is going to be my last time. It's going to, next time I go through here, instead of this 501, this is my last time, but I'm also carrying a -1 because I missed my target. But I hope this makes sense. Basically, I need to know how long my logic lasted. I need to subtract that logic that's already taken place from what my target is, then delay the rest of that target time. And then I need to find out the time again. Did I actually hit the target? And if I'm over it or under it, I can carry it into the next. But I'm only going to allow that carry to be upwards of 50 milliseconds, not more than that, because you can have some crazy stuff happening. I can only allow the adjustment of 50 milliseconds. If you start going past that, you could have it where your game maybe did something weird where it paused too long for a second, and now you are carrying a whole second of time into your next frames, and your game acts really funny and starts speeding up. I don't want that. I want it to just have a little smoothing, but not get crazy. So I hope I explained it. So we'll see it more as we're doing it here, but let's go back to H. So I have this as my actual target that I'm targeting. This is the maximum amount that I'm allowed to be under or over. You know, when if I want to carry a -1 or a 1 millisecond to adjust my next target time for my frame, I'll only allow a maximum, and that's what this number is right here. That's why these are constants. These are not going to change. but I do need to know the time at the end of everything of my last frame. I'm calling it last time. So this one is going to be a time point. So these are durations. This one's actually going to be a time point. I'm getting an actual time point. So this is a type time point of the cron steady clock. So I'm going to call this last time. And that's what this is doing. This is keeping track of the very end after I've paused and all the game stuff has happened and the pause and everything. This is the end of the game loop, the time. Okay, and we also want our carry delay, how much that we were over under our target so that we can adjust the next one. And this one is just a duration again. And we'll call this carry delay. I'll just call this max delay. And that's carry delay. So this is how much I'm going to carry over. This is going to clamp it so it cannot exceed a plus or minus so much. And we also need one of these for the FPS as well, because the FPS is running independently to see what actual FPS I'm getting. So this is the FPS counter. So this is going to be running its own logic that's keeping track of its own time. So we need to know the last FPS time. So this one's going to be just like last time, but this one is separate. It's for the FPS logic that is going to show me what I'm really getting. So it needs to be its own number because it's a real number. It's not just faking a number. And this one's going to be just like this last time right here. So it's going to be a time point. And I'm going to call this last FPS because it's like last time, but it's specifically for the FPS timing. And when I say FPS, I mean the display of the FPS. What you see in the terminal when it's displaying your FPS, that's what this is. So this is the last time of timing the game loop. And this is the last time of, hey, every second I want to say how many frames actually occurred. And that's what this is doing. This is keeping track of that. So we are going to also want the game is going to be based on delta time. So we want some kind of delta time. And so I'm going to keep that in a double and just call it DT. And what this is a fraction of a second. So again, 1/60 of the second would be 16.6666. So if that's how long my frame took, if it took exactly 1/60 of a second, this delta time here would be 16.66, or actually it would be of a second. So it would be 0.166666. That's what it would be. And this is what I would multiply by 300. So I'd take 300 and multiply it by 0.16666, and I would get 5 roughly. It should be 5. So that's what this is going to be. This is going to be used for my movement of my player and my flakes. And we are going to need, again, this is for FPS. We need to count the frames that have occurred. I'm just going to call it frames. It's just an unsigned int. This is for displaying how many frames actually occurred in the FPS printout. And I'm just going to call it frames. And I'm also going to have a Boolean to enable and disable the FPS. The showing of the FPS. The game still times itself no matter what. This is just about showing you and counting the frames. And this last FPS, these 3 right here, are independent in the displaying of the FPS. Okay, so since we have those, we can go into we're not going to have an actual constructor, but we are going to have an initializer, a member initializer list. It's just going to use the default constructor. So for the target duration, this was where I kind of struggled a bit because I was initially using a double to calculate it as a fraction, but it doesn't seem that internally this is a double. It seems it's an int or an unsigned int. So no matter how I tried to do this, it kept coming down to this is an unsigned int. And since there's a division involved, it needs to be at the best resolution it can be at. This is going to make a sense, hopefully, in a second here. So the target duration, right? This is that needs to be that calculation of how many frames per second I want. Now, if I just say, one second divided by, so if I were to do std chrono sec, I could do this seconds right here, one, and then divide it by the target FPS right here. And this isn't going to work. So what it would do is it would be one integer division. So it's going to be 1 divided by 60, which is 0. So my duration is going to be 0. And what's going to happen is the game's going to run flat out. It's going to do that 14,000 frames. This is just 0. It's saying my target is 0 all the time. So this doesn't work at all. And you can monkey around with trying to turn this into a double and everything else, but then you're going to have to cast it no matter what you do. And if I go down to milliseconds, then I'm going to get 16, not 16.6. So then I'm going to actually get 62 frames per second, not 60. And when I go up to 600 frames per second, it's actually going to give me 1,000. And then past that, it's going to mess up. So because again, this is integer division. So what I want to do is the real resolution of this is in nanoseconds. So I'm going to do it in nanoseconds. And just put in 1,000,000,000 here. This is the simplest way. I tried so many different ways to do this. And I was always casting. I was always dealing with a double and then casting. And the real story is this is an int under the hood or an unsigned int. And you just got to go with the nanoseconds. That's what it is. That's the resolution it is. So I'm going to be counting zeros here. So here we go. Here's 1,000. Here's 1,000,000. And there's 1,000,000,000, I believe. Whoop. Sorry, let me just. Yeah, that looks right. Hopefully that's right. Okay. So we'll see it when we actually go because the FPS will be counting. So that's what we're going to do here. We're going to do this integer division, still an integer division, but it's at a resolution that is going to be super high. We're taking 1,000,000,000 dividing it by 60 or 600 or 6,000 or whatever you do. So it's still going to be good enough resolution. And this was the best way. Like I said, I did try a whole bunch of ways. Somebody else may know this better than me. I ended up with very long lines of casting and everything else. I didn't like any of that. So we have that, and we have the max duration. I'm just going to set it to 50 milliseconds. Pretty simple. Max delay, sorry. Max delay. And this is going to be, it's going to be in nanoseconds, but it's going to be, instead of 50 milliseconds, it's going to be, 50 million nanoseconds or something like that. But it's okay. It still works. I can tell it to it in nanoseconds. It's fine. We're not losing in precision because it's not a fraction or anything. So, and you can make this a smaller or larger number. As you see, this is just something I found out with. It seemed to be a reasonable amount of play in either side where you're not noticing anything, but it's giving you a steady FPS. So chrono, so I'm doing milliseconds on this one. And I'm just going to put a 50 here. So I could do this in nanoseconds too, but I would need to add zeros to the back of it. Last time, this one, I want to initialize this to whatever the time is now when the game starts. That's the last time, right? So I'm going to use the cron steady clock now to get the time now to populate this. So this is going to populate it with whatever the time is now. So that will be, now we go through the frame and, it's like it was the last frame time kind of deal. So the carry delay is going to be 0 because, I'm just going to initialize it to the default constructor because there is no carry delay yet. There has no loop happening. This is how things will be in the beginning. So that's just going to be the default, which is going to be nothing. And we have the last FPS, which is just going to be like, now I don't actually need to set this because when I toggle this on, I'm going to do the same thing by doing the now on it. But I'm just going to do this anyway. So it's going to be just like this one. And this is going to be the FPS, the last FPS. Is it? But yeah, last FPS. DT and frames are just going to be nothing. So I can actually just put them here. I don't need to put a 0 in there. And enable FPS will be disabled, which I believe you can just put the curly brackets, but I'm going to explicitly put in false. Enable FPS. So I'm going to get rid of the cron because it was brought in main. Now we are going to need a couple of methods. So we need an update method, which is going to be timing the game. We need the toggle FPS, so we can turn it on or turn it off to show the FPS number. And it actually will only be keeping track of the FPS if it's turned on. And we do need a get DT. This is going to return the delta time so that we can use this in the movement of the player and the flakes. So it's like a getter because I don't want to expose directly the delta time. It's a private, so it's just going to be a getter for that. And a show FPS. And the show FPS is not something that gets called, so it's going to be a private method. It's going to be, if it's been toggled on internally, it's going to, use that. So we'll do the void update. And then we need this toggle FPS. That's for turning on the showing. And we need this get DT. I'm just going to make this an inline because it's just returning DT is all it's doing. And the DT is delta time, if anybody's wondering. And it's not changing anything in the class, so it's const. So, and then there is just this private one because it doesn't need to be exposed. It's just I separated the show FPS logic from the update. So update's just going to actually call this anyway, each frame. So I didn't have a very long method, so I just broke it up. I think in C it's not broken up. It's one long function. Okay, so that is our entire FPS class. So let's jump into the FPS. So I'm going to just start working on the update function. I'm going to skip over the other ones because we can actually use this, test it out just by having the update. We need the update first because that's actually timing our game. So we can actually put it to use and see it without finishing the whole thing. So I need to get the time right now. So I'm just going to call this current time, and I'm going to use auto because I don't want to write that entire type. This is the type that it's returning, and I don't want to type all this. So I'm just going to use auto. Like I said, I generally don't like using auto, but I also don't like the verbose namespace in C++. So this is just current time. It's like, hey, what time is it right now when this function, when this method gets called? And this is going to be called at the end of the game loop. So this is going to be now, not new now. Okay, so that's going to get the time right now. So I can start doing calculations on how much time has passed and all that stuff. Okay, so I'm going to do another one. This is going to be the elapsed time. So I need to know how much time has actually elapsed. That is from the last frame. So imagine at the very end of the last game loop, we got a timestamp. Now we've done the logic of the game loop. We haven't paused the game yet. We've just done the logic. Now this method is being called, and I need to know, hey, what time is it right now? What time was it on the last game loop? Okay, it's been like 3 milliseconds. And I need to know that that 3 milliseconds has passed. This is that's what it is, elapsed time. So elapsed time is going to be the current time that we just got right up here. And it's just going to be subtracted from the last time, which is whatever the time was at the end of our last frame. Okay, so that's kind of give us how much time has elapsed, but now we need to know how much we should sleep for. So this one is sleep. I want these names to line up. Yeah, let's call this max carry. And we'll call this carry duration. So this is how much of the duration that we need to sleep to get us on, to get us lined up with our target duration. So we have our sleep duration is elapsed time plus whatever we carried over. Because remember, our last frame could maybe have been a little too long or a little too short. So we want to adjust this sleep duration based on whatever our last one was. So our sleep duration is going to be, it's going to be a target duration, what we wanted. Target duration minus how much has already passed our lapse time. And then we're going to add to it whatever our incorrect time was from the last time that we did this, our carry. So that's going to be this. How's it carry duration? I think I changed the name of it. Carry duration. So our sleep duration is our target duration, our elapsed, I could have said duration, I don't know, our elapsed time, and our carry duration. Okay. But what happens if this is smaller than 0? Basically, what happens if we've taken too much time? Say we're targeting 16 milliseconds and we have taken 17 milliseconds. Or maybe we took 3 milliseconds, or maybe we took 6 milliseconds, but our last frame took too long by 11 milliseconds or something like that. So we get a negative number. If we get a negative number, then we don't need to sleep at all, right? We only need to sleep if it's a positive number. If it's a negative number, we're definitely not sleeping. So we need to make sure that this number is bigger than 0. So we'll say sleep duration, and we got to use the count method on it. And we want to know, is this bigger than 0? Because if it's smaller than 0, we don't need to sleep. We can't go backwards in time. So if it is bigger than 0, we're going to use this thread sleep for the method that we've already seen. And we're going to have it sleep for the sleep duration. Okay. It's only sleeping if it's more than if there is a reason to sleep, basically. If you're already late, you don't need to pause more time. But if you're early, you need to wait, basically. And it should be early most of the time until you hit a certain wall. Now, after we've slept, we want to find the time again. So I'm going to get the current duration again. Maybe we haven't slept, maybe we have slept. It doesn't hurt for us to get the time again, but if we have slept, we definitely need the time again. So I'm going to use this same thing right here to get the time again. I don't need to use auto down here because this variable has already been initialized. And I also need to calculate the last time again. So this thing is doing right here. Sorry, not the elapsed time. So the reason why is the reason in the beginning, because now that we've slept, now has our elapsed time, is it met? If we meant to sleep for 16 milliseconds, maybe we slept and maybe it's only elapsed 15 or maybe it's elapsed 17. So this is going to deal with how much carry we have going into the next one. So we're saying, okay, now what's the time again? If we've slept or haven't slept or whatever, what's the time again? The elapsed time from this, because this is not really interesting. How much time since the last frame is what we really want to know. So this is going to deal with the carry. So we want the carry delay to be our target duration minus our elapsed time. So this carry duration, how much we're going to carry, it's going to be basically how much we're off by. So it's going to be this target duration, and then it's going to be minus elapsed time. Because my target duration is not really, this isn't set in stone because I'm adding to it this carry duration. This is my actual target duration. This is the real target duration, and this is the elapsed time that has occurred, setting my next carry duration. But we do need to clamp this. We never want our carry duration to be, more than the plus of the max carry or less than the negative max, because this can be a positive or negative number. So we want to make sure that it doesn't exceed one way or the other, a positive or negative version of the max carry. So we'll say if this carry delay is bigger than max carry. So if it is bigger, we're just going to clamp it to it. So this carry duration will equal this max. Okay, so that's that, but we're also going to do it for the negative version as well. Right here, I need a semicolon. Yeah. So we're going to clamp it on the negative version as well. So if this is smaller than negative version, we are going to make it the negative version. So it can't exceed this 50 milliseconds that we set. So this carry duration, it's going to be whatever to keep it on track, but we are not going to let it go beyond 50 milliseconds. And then we need to set the current time that we got right here. The last time we grabbed the timestamp, this is going to be our new last time. Not the first one, but it's using the same name, but the second one. So this is going to be our new last time. So this last time equals the current time. We can set delta time right here. But we're not using it yet, so it doesn't matter. So let's just try this and see if this works. And we don't have anything set up to show FPS. So what we're going to do is just try to set it to 60 and see if the game runs at the right speed. So in game H, I'm just going to make it like the player. I'm just going to put it down at the bottom. Call this FPS. And it's going to complain because it's not brought in yet up here. Oops, this is not supposed to be here. And over here, this FPS reset. I need to go back into to the initializer list as well. Let me just go back before I forget and fix that in game. So right here, there we go. FPS is null pointer. Okay, so we have this right here and the game right here and the deconstructor. I'm just going to put it here with the other classes. Okay, so that is bringing the FPS online here, and it is cleaning it up here in the custom deconstructor. So now that we have it, we can go down to here, and I'm just going to comment this out. Now, the game would run at max speed, and it would be crazy fast because, well, I could just show it real quick. And we are doing that one, yeah. It's going to be crazy fast because there is no timing right now, so it's just going to run the game at max. Max delay. FPS 15. I kept changing these names around. So this one is max carry. And this one is carry duration. Just trying to get the names in line with each other so they make more logical sense. They were named differently in the C code and everything else. So what we're going to see is the game should run really fast right now. Yeah, I can't even move the character. It's just instant. Okay, so no timing happening at all. Now we will go into game and we will put our new class update here. And we should be targeting 60, so it should act normal. And this is update. And I don't need to do a clean. Okay, it looks like it's running correctly now. We can't check it because we haven't implemented the show FPS or anything like that yet. So, and we haven't implemented delta time. So if we do change the FPS right now on this, as you saw in the last time, it would just run really fast or really slow. So we haven't implemented delta time, but that's going to be very easy. We've done the hard bit. Just deleting that line we don't need. So that's good. Let's implement the showing of the FPS and then we'll implement the delta time. So the showing of the FPS is pretty straightforward. So we do need a function to toggle it or a method to toggle it and the other method to actually show it. Okay, so I'm going to put the toggle one in first. We've already put these in the header file, so they've already been declared. We're just defining them now. FPS toggle. So toggle FPS kind of turns it on or off. And the one thing that we need to do is actually toggle the Boolean, the enable FPS. So if FPS is enabled, we're going to disable it. Okay, that's pretty straightforward. On the else, if it's not enabled, we're going to enable it. But we also want to set our frames to 0 because we're counting frames, right? So frames need to be set to 0. And we need to get the current time because this thing is going to be checking to see if like a second has passed. If a second has passed, it's going to show us how many frames has been counted since that last second. So since we don't, the only way we know if a second has passed is we need to set the time right now to our last time, our last FPS time. Because if this FPS hasn't been turned on and we've been playing for 5 minutes and then we go to turn it on, it's going to say, yeah, a second has passed, 5 minutes has passed. So it's going to tell us nonsense numbers. So we need to kind of reset the last FPS to turn it on. So this it's not last time, it's last FPS time. And we're just going to basically grab that timestamp right now because we're turning it on now. So the steady clock and then now. And that's all that we need to do to toggle it on. So whenever we're turning off, we just disable it. But when we turn it on, we need to reset the frames so they're set at 0. And we need to make sure our last FPS time is right now. So that's how we're initializing every time we turn it on. So now how do we count the frames? That's pretty simple too. And we'll call this show FPS. And this is only going to be run if FPS is enabled. If it's not enabled, it's just going to kind of skip past it real quick. So if it is enabled, we need to grab the current time. So there's our current time, just like we did here. This is we're setting it as our, the last time point. This is saying, hey, what's the time right now? Now we need to see if a second has passed. So if current time, and I want to know if it's bigger or equal to the last FPS time plus 1 second. So I'm just going to put last FPS and then the chrono seconds 1. Last FPS plus, and I'm just going to put 1 second here. So if that has happened, what are we going to do? Well, we're just going to print out how many frames we currently have. Okay, so just printing out the frames. And because we haven't seen that we're counting frames, but we're counting frames. We're going to take the last time and we're going to add a second to it. Last FPS, sorry, not last time, last FPS. And we'll do a plus equals. I think we can do that. If we can't, we'll just do it the other way. My notes have it the other way. Okay, so we added a second. So now the next time it prints out will be a second from now. And we're going to set the frames back to 0 again. So this is all if a second has passed since this was set or since the last time it was updated. If not, we are going to update the frames. And that's it. That's our that's how we're keeping track of the frames. So right here it doesn't look right. Okay, I had 2 colons there instead of an equal sign. So yeah, so we're just grabbing the time, seeing if that time is what our last timestamp was that we counted plus 1 second. That means 1 second has passed. And if 1 second has passed, we're going to print out how many frames we counted. We are going to add 1 second to our last time. So it'll be the next second from now that we do it again. And we're setting our frames to 0. If a second hasn't passed, we are adding frames. Okay, so that's very simple and it's decoupled. It's doing its own timing other than this. So it's telling you how many real frames it counted 1 second at a time. So what we need to do here is we're going to call this method from the bottom of this. So it doesn't need to be called separately. It's actually always called, but it's only doing anything if it's been enabled. And so that is all set now. Let's check that out. We haven't set it up in game in the events. I'm going to put it on F and it's going to be the toggle. So scan code F and it's going to be this FPS, toggle FPS, break. So now if we press F, it should turn on or off FPS. Every time we turn it on, remember we're resetting it and grabbing a new timestamp. We turn it off, we're just disabling it. It's no longer going to be, even though the method gets called, no logic happens. Okay, so I'm going to press F and we're getting 60. Okay. Now the problem is we're still tied physically to every time we update, we're moving 5 pixels. So now we need to decouple this. We need our delta time. Because right now, if I were to change this to 30 FPS, the game would play slowly. If I changed it to 120 or higher, it would play very fast. And we don't want it to do that. We want to decouple this. So the first thing we need to do is go back into FPS. And we just need to add one tiny little thing. We just need to update our DT double. So right here on this elapsed time, how much time has elapsed? This is where we're getting our delta time from. So this DT, and what we're going to do is we're getting the elapsed time divided by a second. So STD chrono duration and we want this to be a double because DT is a double. This duration is not really being held as a double. So we're going to kind of cast it or whatever. We're doing it as a double for our elapsed time. And we're dividing it by whatever our cron second is. Okay, so it's basically our duration divided by a second. Or our elapsed time. How much time actually occurred in this frame. Imagine if it was in milliseconds and 16 milliseconds happened. We don't want 16. We want 0.016. So that is, if we were in milliseconds and that was 16, that would be 1,000. We would have to take 16 and divide it by 1,000. This is in nanoseconds though, but this thing is taking care of it for us. This is just saying, hey, whatever a second is, divide this duration by a second. So if it's in nanoseconds, this would be a billion. It doesn't matter. It's figuring it out for us, and we want it as a double, and that's going to be what's here. And so we're going to take this. Imagine again, if it was in milliseconds, if it was 16 milliseconds, it would be 0.016. And if we had 300 as our target pixels per second, and we multiplied it by that 0.016 and 6 onto infinity, we would get about 5. And if we were to slow that down to half that speed, it would give us twice as much. So it's always going to be correct based on whatever the amount that the last frame took. Okay, so this is delta time. So we have this dt. We already have an inline method that returns dt. So we have that get dt that we've already set up in right here. This just returns it. So now we have access to delta time. Now we just need to switch over our movement to use delta time. So if we go to flakes, we have a problem here. This is an int. Okay, so this rect.y is an int, and there's a kind of two problems here. One is we would have the double to an int is a problem, but the other thing is what if we need to move? What if our frame rate is so high that we're not moving 5 pixels? What if we're doing it at 600 FPS instead of 60? Instead of 5 pixels per frame on average that we're moving, we would be moving 0.5. Now, if it's an int, 0.5 turns into 0 and we never move. So we can't control our movement based on this rectangle anymore. We need to hold a double that is actually our precise place and control it there. So our delta time is already a double. We need to have our rect y. We need to have that position y as a double as well. And then we will allow the rect to do whatever it is at that time. So imagine if we hold our position y as a double and it's 0, and then we tell our rect to be the same thing, it's going to be 0. If it now gets updated to being 0.5, our rect is still going to be 0. But if we update it again with another 0.5, now it's 1, our rect is going to be 1. And then 1.5, our rect is still 1. 2, our rect is 2 now. So we keep our high accuracy in a double, but we do mix it down to the rect so it can be displayed on the screen. But we are always keeping our precise movement as a double. So we need to do this. So I'm going to add a double for position y. I don't need it for x because x is not moving, so it's only y that's moving. And I'm just going to set it to nothing. On our update, we need to be able to take in delta time. So I'm going to add a parameter. So we're going to be passing in a double to this, which is going to be our delta time. Okay, so go back into Flake. Now it's complaining about this because we need our double dt. So now our updating and everything is going to be happening with the double. This plus equals flake velocity. And this flake velocity right now is set to 5. I'm going to change it to 300. But it needs to be multiplied by dt. But again, we don't want to hold it in this int because we're going to have all kinds of problems with that. So we want this pause y. Okay, so we do need to change this number. I'm going to change it before I forget. The flake velocity is 5. That's 5 pixels for every frame instead of 300 pixels per second, which is the same. And I'm going to do it for player 2, which is also 5, so I don't have to come back and do it. Okay, so back into flake. So we have this, we're updating this high precision now, where we have the flake velocity is 300 times dt, which is going to be a number smaller than 1. So we have this flake that's being updated by this small number, which gets smaller the faster the FPS is and gets bigger the slower the FPS is. But we still need to do everything else that we do with the flake. So right away, I'm going to take this high precision number and reset the rect y based on it. And I need to cast it to an int. Depending on what compiling flags we have, it might complain. Because I'm taking it double and to an int. So this one's keeping track of the movement in the high precision, and then this is just the output for checking the bottom and doing all the other stuff that it needs to do. But we also need to do something up here. When we reset the flake, we need to know the position y needs to be the same as the flake. So when we reset it, we're basing it on an int, which is fine. We just need to make sure our position y matches that. So we can just do that. So whenever we do it, these two are lined up, they're the same. And then each time we're updating, we're holding our high precision in here, and we're always mixing it down to here for this, but this is still holding the high precision for the next time. So any fractions or anything else are still updated correctly. And that should get our movement of our flake for delta time. And so we can do the same thing in player, where we need this high precision, and this one's on the x instead of the y. So pause x, and up here, so in player CPP, we're going to basically be doing the same thing. So when we set it here, we need to do the same thing. Pause x is just going to equal, and we don't need to worry about going from an int to a double. That's fine. So that's setting that up just fine. Now for our movements, this needs to be delta. So we need to set that in the header. Okay. Now in this one, same thing. It's going to be multiplied by delta time. And it's going to be stored in pause x. And then right away, we do need to adjust these two. This becomes a problem because this is resetting the position. When we reset the position, we need to make sure pause x is also been reset. So we'll need to do that in a second here. So I'm going to go this rect x equals, we're going to an int. Pause x. That's going to be fine. I'm just going to do the same thing right on the next one. Actually, this is all going to be the same except for the positive it's going to be positive. Okay, so that's on the positive. That's the same. So we have the problem with this set right and set left. This is an issue. I think that's in the header. right here, these two, we need to add something to them. So when we do change, we need to go ahead and set the pause as well. So that'll need to be done on both of them. Okay. So when we go into game, it's going to complain because we're not passing in the DT yet. And then we can try it out. So let's go into game, and it should be complaining here. Yeah, for the player update and the flake update. So we can get the DT from the FPS get DT. Should be like that. DT. Okay, so let's try that. If it's working correctly, we won't see any difference. Okay, looks like the flake is following the correct speed. Press F. Okay, cool. So what I'm going to do is I'm going to put it to 600. So this will be running 10 times faster. We should be able to notice if there's a difference in gameplay. Okay, it looks like it's running the same speed. Press an F. We're getting 600. That's cool. I'm going to do it to say 15, which should be a quarter of the speed or that it should be running at. Just to make sure. It's going to be choppy, but it should be moving at the correct speed. Okay, looks like everything's moving in the correct speed. It's just choppy because it's only 15 FPS. And pressing F, looks like I have 15. Looks good. Yeah. Okay, that all looks great. I'm just going to change this back to 60 before I forget. So it looks like everything is working as expected. So this also means that, remember, regardless of what number you put here, if your hardware itself or the target hardware somebody else is playing on is fluctuating if it's fluctuating its FPS, it doesn't matter as much because the game will still play at the right speed. When it goes down too slow, obviously it becomes choppy, but it's as good as it can be. Okay, so this is one way to set the FPS. I'm sure there's other ways as well, but so let's just cover what we've done here. We have gone into, we basically are using the cron steady clock. We have a target duration, which is our fraction of a second that we're targeting for our whole game loop to run. We have the maximum amount of adjustment we're allowing to add or remove from the next one. This gets our last time point from the end of our last frame, so we know where we're at. This is how much we're actually carrying if we need a plus or minus to the next frame. This is separately, this is part of showing the FPS. This is the last time for the FPS. This is how many frames it's counting for the FPS. This is if the FPS is enabled. And this is the delta time that we can return back to make our movement decoupled from the actual frame rate. So up here, we're setting this target FPS, which right now is set to 60. I'm taking this, this is in nanoseconds, and you can change this to milliseconds, except it won't run at 60, it'll run at 62 because you've lost because of the integer division. So anyway, this is 1 billion nanoseconds divided by whatever your target FPS is set for the target duration. all these durations are done in nanoseconds. The maximum carry, I've set it to 50 milliseconds, which will be in nanoseconds, will be like 50 million or whatever that number is. The last time I'm setting it when you instance this class, it's getting the now time. Same with the FPS, but the FPS every time you enable it is also doing the same thing. These are set to 0. The show FPS is set to false. There is an update. This is what's timing the game. There is a toggle to show the FPS to show it on or off. There is an inline get DT, which gets the delta time, returns it so you can use it for the movement of the player and the movement of the flakes. And then I just separated out the logic of showing the FPS from the update. So this is just the other part of the method. It's not called externally. And the types are all steady clock duration or time point from the steady clock. And we have the doubles. We have just unsigned in for frames and Boolean. So in here, what we're doing is we're grabbing the time. We're seeing how much time has passed since at the end of the last game loop. Then we are setting our sleep duration based on how much duration we wanted our entire loop to be, minus how much time has happened since the last loop, plus any adjustment that we have, our carry duration, which is adjustment from if the last frame has been overshot or undershot our target. If this is a positive number, we need to sleep. It's most likely going to be a positive number unless you're set at like 14,000 frames a second. If you're set at 60, it's definitely going to be a positive number. It's going to need to go to sleep. So then we need to grab the time again, the same thing again, find out what the elapsed time was. This last time grab that here is actually our last time that we're setting down here. We're setting our last time down here for the next game loop. This elapsed time right here is what's being calculated for DT. We're doing it as a double and we're dividing by 1 second so we can get whatever number that we need to be. So we can multiply this by our movement. Our carry duration is going to be whatever our target duration plus the adjustment minus our actual elapsed time. And this may go out of scope, out of our maximum carry that we want to happen. So we're clamping it. If the number is too big, we're clamping it to the high end. If it's too small in the negative, we're clamping it to the low end. And we're setting our last time now to whatever this current one that was grabbed right up there. Now we're just running, we're just doing our logic for our show FPS, which is right here. I could have just grabbed this and dropped it in this spot right here, but it's just separated. So this one, if it is enabled, we're grabbing the current time. We're making sure our last time plus 1 second hasn't been exceeded. If it has, we are showing how many frames we got. And we are setting the last frame, the last FPS time to whatever that time was plus 1 more second. So we'll hit it again in another second and we're setting our frames to 0. If not, we're clicking our frames up by 1. This is just turning on or off the show FPS. With the Boolean, we are setting our frames to 0 and setting the time, the last FPS time to the current time. So it will count for 1 second and then show. Okay, this doesn't need to be here. Okay, so all that is timing our game. And then as you've seen in our player and flakes, we are adding a position X as a double. And we are also adding a DT into our update. And so when we do update, we can use this DT. We can multiply it by the player velocity, which is no longer 5, it's 300. Because we're multiplying it by a small number here to get our precision double as our position X. And then this is to keep the high precision track of it. This is to actually use it and to do the rest of our logic. But anytime we change this X, like even up here, we need to also set our position X, or in the inlines, right here where we're resetting the X position, the position Y needs to also be reset with it, or you'll have weird glitches where your character will move and then move back again. I hope I explained everything. If you have any questions, just feel free to ask in the video. I hope you learned something or enjoyed that, and have a good day. I'll see you in the next one. Bye.